B-roll. Slow push into a satellite loop of a gray plume spreading over the dark ocean. At 4:30 in the morning, Coordinated Universal Time, on July 22nd, a satellite in geostationary orbit drew a shape over the North Pacific, 4 corners, a polygon of volcanic ash. And one of those corners was in the Western Hemisphere. The cloud had crossed the international dateline. Nobody announced it. It was written into a routine aviation message, in numbers most people will never read. But those numbers are the reason you're watching this. Because that ash did not come from Alaska. It did not come from anywhere in North America. It came from a mountain on the far side of the Pacific Ocean in the Russian Far East called Sheveluch. And here's the part that should make you sit up. The eruption that produced that cloud was not the big one. It was routine. It was one of at least 7 this month alone, and Sheveluch has been doing this over and over since January, which raises the question that this entire video is built around. If this is what a normal week looks like, what does the abnormal one look like? By the end of this video, you will understand exactly why volcanologists have been quietly watching one specific structure on this mountain since December, why they cannot see inside it, and why the last time that structure reached the stage it's at right now, it collapsed and rewrote 100 square kilometers of landscape in 90 minutes. We're going to walk through it in order. The mountain, the mechanism, the collapse that happened in 1964, the one that happened in 2023, and what has been growing since December of last year. Before we go further, if you want the story the headlines skip, the one that lives in the raw monitoring data instead of the press release, subscribe. This channel is where it drops first, and this one is still developing as you watch. B-roll, wide aerial of Kamchatka's volcanic spine, snow and black rock. To understand what's happening now, we have to go back. Not to July, not even to 2023. We have to start with what kind of mountain this is. Sheveluch sits at the northern end of the Kamchatka Peninsula, a narrow finger of land hanging off eastern Russia into the North Pacific. Its summit stands at 3,283 meters, 10,771 feet. The nearest village, Kluchi, is about 50 kilometers away. Petropavlovsk-Kamchatsky, the regional capital, is 450 kilometers to the south. That distance is the first thing to hold on to, because it is exactly why most of the world has never heard this volcano's name, and exactly why it can do things other volcanoes cannot get away with. Kamchatka exists because of a collision. The Pacific Plate is sliding beneath the edge of the continent along the Kuril-Kamchatka Trench, one of the fastest converging subduction zones on Earth. Ocean floor goes down, water comes off it. That water lowers the melting point of the rock above and magma rises. That's the engine. It has been running for millions of years, and it has built a peninsula with more than 30 active volcanoes on it. Sheveluch is not just one of them. By volume, it is one of the largest volcanic structures in the entire arc, roughly 1,300 cubic kilometers of accumulated rock. And according to the Smithsonian Institution's Global Volcanism Program, it has produced at least 60 large eruptions in the last 10,000 years. 60 in the Holocene. That is not a volcano that erupts. That is a volcano that is essentially always erupting, with pauses. But here's where it stops being an ordinary big volcano. Pattern interrupt. Because the thing that makes Sheveluch genuinely dangerous isn't its size. It's the chemistry of what comes out of it. B-roll, slow-motion viscous lava, thick and crawling. When most people picture an eruption, they picture Hawaii, orange rivers, fountains, lava moving downhill like water. Sheveluch does not do that. It cannot. Sheveluch erupts andesite and dacite, magma with a high silica content, somewhere in the region of 60 to 64% by weight in the rocks researchers have sampled. Silica changes everything. At a molecular level, silicon and oxygen link into long chains, and those chains tangle. The more silica, the more tangled. The more tangled, the thicker the melt. Low silica basalt pours. High silica andesite crawls. It behaves less like liquid and more like hot tar being pushed through a straw. And that matters for one reason above all others: gas. Every magma carries dissolved gas: water vapor, carbon dioxide, sulfur dioxide. In runny basalt, those gases bubble out gradually as the pressure drops. The system burps continuously. It never builds up. In thick andesite, the bubbles cannot escape. The melt holds them. Pressure accumulates. And it keeps accumulating until it finds a way out all at once. That is the difference between a lava flow and an explosion. So what does Sheveluch build instead of a lava flow? It builds a dome. B-roll, thermal satellite imagery, hotspot in a crater. A lava dome is what happens when magma is too thick to run away from its own vent. It squeezes up. It piles on top of the opening. The outside cools and hardens into a crust of gray fractured rock. The inside stays hot, stays pressurized, stays full of gas. And underneath it, fresh magma keeps arriving. So the dome grows, upward, outward, steeper, taller. Blocks break off the edges and tumble down the flanks as hot avalanches. Cracks open across the surface. Sometimes a spine of solid rock is extruded straight up like a tooth pushing through a gum. Sheveluch did exactly that in 1993 and again in 2020. Now picture what that structure actually is. It is a steep, heavily fractured pile of partly cooled rock sitting directly on top of a pressurized gas and magma system being pushed from below on the side of a mountain. It is a lid made of rubble, held down by nothing but its own weight. Pattern interrupt. And that leads to the single most important sentence in this video. The danger of a dome volcano is not the eruption. It's the removal of the lid, because when a large piece of that dome fails, when it slides, when it shears off, the weight sitting on the magma disappears in seconds. The pressure that was being contained is suddenly not contained. And the magma, which is full of gas that has had nowhere to go, does what a shaken bottle does when the cap comes off sideways. It doesn't erupt upward, it erupts outward. Volcanologists have a name for that. They call it a Péléan eruption, after Mont Pelée on Martinique, where in 1902 a collapse-driven blast killed almost the entire population of the town of Saint-Pierre in a matter of minutes. The result is a pyroclastic density current, a ground-hugging avalanche of gas, ash, and rock fragments, hot enough to ignite whatever it touches, moving at highway speed and faster. You do not outrun it. Nobody has ever outrun one. And Sheveluch has produced them repeatedly. The floor of its own caldera, a 9-kilometer-wide bowl left over from a late Pleistocene collapse, is largely paved with the deposits of its own past failures. Rehook, which brings us to the date this whole story really hinges on. B-roll, grainy archive-style black and white, then modern hummocky terrain from the air. November the 12th, 1964. Sheveluch had been restless for weeks. Seismicity had been climbing. This was not a bolt from a clear sky. The instruments of the day were recording something building. At 7 minutes past 7 in the morning, local time, the mountain failed. Not erupted. Failed. A magnitude 5.1 earthquake struck. And analysis of the seismic records suggests that quake was associated with magma pushing up into the edifice itself. Then, more than a cubic kilometer of the volcano came apart. Published reconstructions of the deposits put the collapsing mass at roughly 1.15 cubic kilometers, with the resulting debris avalanche estimated at around 1.5 cubic kilometers of material. That avalanche traveled more than 15 kilometers from the vent. It buried approximately 100 square kilometers of landscape. Then, with the lid gone, the mountain did the rest, a phreatic blast. Then, between about 20 past 7 and quarter to 8, 27 minutes, a full Plinian eruption, throwing out around 0.3 of a cubic kilometer of fresh magma as tephra. And then from roughly quarter to 8 until 20 past 8, pyroclastic flows, between 3 and 0.5 of a cubic kilometer of them. The column reached somewhere between 10 and 15 kilometers. It carved a new crater about 2 kilometers across. In the villages, people heard thunder rolling out of the ash column as lightning discharged inside it. Total elapsed time from first failure to final flow, about 75 minutes. Now hold this next fact in your head, because it reframes everything. That directed collapse-driven blast happened in 1964. Mount St. Helens, the eruption that taught the world the phrase lateral blast, that is in every textbook, that every American schoolchild learns about, happened in 1980. Sheveluch did it 16 years earlier, in a place with almost nobody to see it, which is precisely why you've never heard of it. Open loop. And here's the part that matters for July 2026. After 1964, that new crater didn't stay empty. B-roll, time-lapse style satellite comparison shots. In 1980, inside the scar left by the 1964 collapse, a new dome began to grow. Volcanologists named it Young Sheveluch. And for the next 4 decades, it did exactly what dome volcanoes do. It grew, it cracked, it shed avalanches, it exploded, it partially collapsed, it grew again. Grow, fail, rebuild, grow, fail, rebuild. Each cycle a little different, each one ending the same way. That is not a volcano cooling down. That is a volcano cycling, with fresh magma arriving from depth to reload it every single time. By 2022, researchers had started saying out loud what the data implied. The dome was in an unstable state, and a large eruption was expected. Not predicted to the day, expected. As in, this structure is loaded and the cycle is due. Pattern interrupt. And then it happened. B-roll. Night footage of an ash column with internal lightning, ash-covered village streets. On the 10th and 11th of April 2023, Sheveluch produced its largest eruption in around 60 years. The plume reached roughly 20 kilometers. 20 kilometers. That's past the top of the troposphere. That's material being injected into the stratosphere. where there is no weather to rain it out, and where it can travel for weeks. The resulting ash cloud spread across an area reported at over 108,000 square kilometers. In Kliuchi, the village 50 kilometers away, ash fell to a depth of about 8.5 centimeters. Not dust, not a film on a car, 8.5 centimeters of abrasive volcanic glass on rooftops, roads, and machinery. The eruption released an estimated 200,000 tons of sulfur dioxide into the upper atmosphere. And when researchers examined the satellite imagery afterwards, they classified what had happened. Palaeon, a dome collapse triggered lateral blast, the same mechanism as 1964, the same mechanism as Mont Pelée. The lid came off, and the mountain unloaded sideways. It left behind a collapse scar measured at roughly 2 by 2.6 kilometers. Rehook. So now there's a hole, a fresh open scar where the dome used to be. And I want you to ask the question that volcanologists asked in the days afterwards: what fills a hole like that? Because you already know the answer. You've watched this volcano do it twice in this video already. B-roll, infrared satellite thermal anomaly, tight crop pulsing. For most of 2024 and 2025, Sheveluch stayed at what monitoring agencies call Aviation color code orange. Elevated, erupting. Not alarming. Thermal anomalies in the crater most days. Occasional ash. Weeks where cloud cover meant nobody could see anything at all. A second dome, on the southwest flank of Old Sheveluch, had been growing since 2024, originally called Karan 1, later renamed 300 Years of RAS. Routine for this mountain. Then, at the very end of December 2025, the Kamchatka Volcanological Station recorded something specific. A new lava dome began extruding on the western part of the dome on the crater floor of young Sheveluch. A new one, not growth of the old one, a new extrusion point inside the crater. Through January and February of 2026, that new dome produced ash plumes reaching 9 kilometers. And then, at the end of February, came the observation that is the reason this video exists. Slow down. Land this. By the end of February 2026, the new dome was higher than the young Sheveluch dome. 2 months old. Already taller than the structure it grew beside. Let me tell you why that single sentence is the most important thing in this entire story. B-roll. Simple animated cross-section. Crater walls, dome rising past the rim, go back to what a dome actually is. A steep pile of fractured rock over a pressurized vent. When that pile is growing inside a crater, the crater walls do something useful. They buttress it. They hold the sides in. A dome contained by rock on 3 or 4 sides can pile up higher than it otherwise could, because it is being physically supported. But that support has a ceiling, literally. Once the dome grows past the height of the walls containing it, the buttressing is gone. Above that line, the structure is supporting itself. Steep, fractured, hot inside, pressurized from below, and now unconfined. A dome that has outgrown its container is not the same object it was a month earlier. Its failure modes have changed. Now, I want to be precise here, because this is where a lot of channels start lying to you. Nobody has said this dome is about to collapse. No agency has issued that warning. The aviation color code has spent 2026 at orange, kicked up to red for a few hours at a time during individual explosions, and then lowered again. What I'm telling you is what the monitoring record says. A structure that did not exist in November 2025 has, in 8 months, grown past the height of the dome beside it and started producing explosions to 12 kilometers on a near-weekly basis. That's not a prediction. That's a description. Pattern interrupt. And the description gets stranger when you lay 2026 out month by month. B-roll. Timeline, graphic building, ash heights as rising bars. Here's what the KVERT and Global Volcanism Program records show for this year. I'm going to move fast because the pattern matters more than any single line. January the 23rd. Explosion sent ash to 10 kilometers. Color code raised to red. Within 2 hours, the leading edge of the cloud is 322 kilometers from the summit. February the 2nd through the 8th, red, then orange, then red, then orange, then red again. Plumes at 11 kilometers, 11.5, and on the 8th of February, 11.6 kilometers, 38,100 feet. Observers note glowing ash plumes at night with frequent lightning inside them. February the 22nd, more explosions, plumes drifting 500 kilometers. March the 16th, 11 kilometers, and the cloud drifts more than 1,800 kilometers east. March the 19th to the 22nd, plumes to 11.6 kilometers. Ash tracked 2,410 kilometers downwind. March the 27th, 29th, and 31st. 3 separate events, up to 12 kilometers. One cloud runs 1,550 kilometers east. April the 2nd, 11 kilometers, red. Within 1 hour, the ash has moved 563 kilometers northeast. By the next day, 890. April the 5th, 6th, and 7th, Red, orange, red, orange, red, orange. 3 escalations in 3 days. April the 8th, a cloud drifts 1,600 kilometers. May the 20th, satellite images the next day show ash has traveled about 2,300 kilometers east. May the 22nd, 1,780 kilometers east-southeast. May the 24th, 10 kilometers red and plumes drifting roughly 1,850 kilometers south and southeast. June the 6th, explosive and extrusive activity escalates. 12 kilometers, 39,400 feet, within 5 minutes of the event starting. Red. June the 8th, 10 kilometers. Red again. The resulting cloud measures 250 by 230 kilometers. Rehook, and then July arrives, and the spacing between events collapses. B-roll. Rapid cut satellite loops. Timestamps burned in. July the 2nd. An explosion at or 8:54 UTC puts ash at 11 kilometers, 36,100 feet. July the 3rd. Another. 10.5 kilometers. By 9 that evening, the cloud extends 63 kilometers northwest. Monitoring notes describe continuing explosive extrusive activity, powerful gas and steam emissions, and this is the line to catch, the growth of a new lava block in the northern part of the dome. The thing is still building itself. Mid-eruption. July the 5th, 07 to 16, UTC. Ash to 12 kilometers. 9 minutes later, 12.2, 40,000 feet. Video confirms an explosion lasting about 10 minutes. The color code goes red at 0736. Later that day, the ash cloud, measured at 222 by 45 kilometers, is sitting over Yelizovo Airport and Petropavlovsk-Kamchatsky. That is the regional capital, 450 kilometers from the volcano, with ash overhead. July the 9th, 21.43. Local. Plumes to 10 kilometers drifting 30 kilometers east. Red at 22:39. No further explosions overnight, so the code drops to orange at 05:21. And by then, the previous day's cloud measures 440 by 62 kilometers, with its center 885 kilometers from the mountain. July the 16th. Tokyo's Volcanic Ash Advisory Center logs an ash cloud at flight level 230, 23,000 feet. That is not near an airport. That is inside the band where aircraft actually cruise. July the 19th. Between 07 to 17 and 07 to 32, local time, satellite data analyzed by the Kamchatka branch of the Russian Academy of Sciences Geophysical Service shows an ash plume at approximately 12,000 meters above sea level. 12 kilometers. Again, 15 minutes of it, pattern interrupt. And on the 21st, something happens that changes which country's institutions are involved. B-roll, Pacific map, dateline drawn as a thin vertical line, plume polygon animating across it. There are 9 volcanic ash advisory centers in the world. Each one owns a slice of the planet. Tokyo owns the Russian Far East and the Western Pacific. Anchorage owns Alaska and the North Pacific approaches. Washington owns North America. Ash from Kamchatka is Tokyo's business. That is how it normally works. On the 21st of July at 04:39 UTC, the Washington VAAC issued an advisory naming Sheveluch, sourced from Anchorage. The center responsible for North American airspace put out a message about a Russian volcano, beat. And then, the next day, came the numbers I opened this video with. At 05:06 UTC on the 22nd of July, Tokyo issued advisory number 2076 for Sheveluch, based on Himawari 9 imagery, observation time stamped 04:30. The message described an ash cloud from the surface up to flight level 350, 35,000 feet, and listed the corners of that cloud as coordinates. I'm going to read 2 of them. North 60 degrees 57, east 179.54, north 60 degrees 10, west 179.49. Look at those 2 numbers, east 179 and west 179. That is the same line. That is the international date line. The ash cloud was straddling it. One edge in tomorrow, one edge in today. Part of it was, by longitude, in the western hemisphere, over the Bering Sea on the American side of the map. The message recorded it moving northeast at 100 knots, about 185 kilometers an hour, and then the forecast section. 6 hours ahead. Ash from the surface to flight level 370, 37,000 feet, which is exactly where long-haul jets cruise, with a corner placed at north 6217, west 159.47, 159 degrees west. That is a longitude that runs through mainland Alaska. Immediately open the next loop. Now, and this is the difference between this channel and the ones that only want your click. That last number is a forecast polygon, not a measurement. It is a dispersion model's projection of where thinly dispersed ash could be, not a photograph of a black cloud over Anchorage. Forecast areas are drawn generously on purpose because the entire point of the system is to be conservative when aircraft are involved. Nobody in Alaska was told to look at the sky. There is no ashfall in North America. But that raises a far more uncomfortable question. If a routine week at Sheveluch pushes forecast ash to Alaskan longitudes at cruising altitude, what is the system holding in reserve for the week that isn't routine? B-roll, turbine blades, cockpit instruments, night flight. To answer that, you need to understand why anybody is drawing these polygons at all. Volcanic ash is not smoke. Wildfire smoke is soft carbon particles, unpleasant, but at cruise altitude, mechanically harmless to an engine. Volcanic ash is pulverized rock and volcanic glass. Magma shattered into microscopic fragments by explosive decompression. Hard, angular, abrasive, and it has a melting point that sits below the operating temperature inside a jet engine. So ash enters the intake as dust. It melts in the combustor. Then it hits the cooler turbine section behind it and resolidifies as glass on the blades in the cooling holes. The engine glazes itself shut from the inside. At the same time, the abrasive fraction sandblasts the windscreen until the crew can barely see through it and contaminates the sensors that tell the aircraft how fast it is going. This is not theoretical. It has happened twice in the way that defined modern policy. In June 1982, a British Airways 747 over Indonesia flew into ash from Mount Galunggung at night. Nothing on radar, nothing visible. All 4 engines flamed out. The aircraft glided while the crew ran restart drill after restart drill. Engines eventually relit. They landed. In December 1989, a KLM 747 flew into the ash cloud from Mount Redoubt during descent, over Alaska. All 4 engines failed. The aircraft lost thousands of feet before they were restarted. They landed. 2 aircraft, 8 engines, 2 survivors. Pattern interrupt. And here is the detail that makes it worse. Aircraft weather radar cannot reliably see volcanic ash. Weather radar works by bouncing energy off water droplets. It is superb at finding thunderstorms. Ash particles are dry, small, and return almost nothing. Which means the one instrument in front of a pilot that exists specifically to say, don't fly into that, is the instrument that goes quiet. At night, mixed into ordinary clouds, ash is invisible to the eye and invisible to the radar. The first indication that you have entered it can be the engine parameters starting to move. That is why the advisory system exists. That is why Anchorage was created, because Alaskan and Kamchatkan volcanoes sit directly under the busiest long-haul corridor in the northern hemisphere. The Great Circle routes between Tokyo, Seoul, Beijing, Shanghai, and the airports of North America do not cross the middle of the Pacific. The shortest path curves north, over the Aleutians, over Alaska. Straight through the airspace Kamchatka's ash drifts into, hundreds of flights a day, through the exact box where that polygon was drawn, rehook, which brings us back to the mountain and to the one thing nobody can actually see. B-roll, satellite view obscured by weather cloud, blank gray. Here is the uncomfortable truth at the center of this story. Everything I have described, every plume height, every cloud dimension, every color code, is an observation of what has already left the volcano. None of it tells you the state of the dome. A 12-kilometer column proves an explosion happened. It does not tell you how much of the dome moved. It does not tell you whether internal fractures are spreading. It does not tell you whether the base of the structure is being undermined by each successive blast. The measurements that would answer those questions are taken on the mountain itself. Dense seismic networks listening to rock cracking inside the pile. Deformation instruments watching for the surface to swell or slump by centimeters. Gas flux monitoring, tracking whether sulfur dioxide output is climbing. And Sheveluch is remote, weather-beaten, and hard to reach. Read the weekly reports and you will find the same phrase over and over, month after month. Weather clouds obscured views, sometimes for a day, sometimes for most of a week. There are stretches this year where the honest summary of what was happening at that summit is, we don't know, it was cloudy. Open loop. And that leads to a genuine unresolved disagreement that no satellite can settle from orbit. There are 2 ways to read a sequence of frequent, moderate explosions at a dome volcano. Both are held by serious people. Reading 1, the safety valve. Every explosion vents gas. Every vent lowers pressure. A dome that depressurizes itself regularly never accumulates enough stored energy to fail catastrophically. On this reading, the noisy months are the safe months. And the thing to fear is silence. Reading 2, the slow demolition. Every explosion fractures rock. Every partial collapse removes material that was supporting the mass above it. The structure isn't relieving stress. It is being taken apart from the inside, one event at a time, until a piece large enough to matter finally lets go. On this reading, the noisy months are the countdown. Sheveluch's own history contains examples of both, which is why nobody can tell you, today, which one you're watching. What the record can tell you is this. Fresh magma is still arriving from depth. You do not get near weekly 12-kilometer columns from a system that has stopped being fed. The dome is still building. Observers logged a new lava block growing on its northern side on the 3rd of July, in the middle of the eruptive sequence, and the structure has already outgrown the walls that were supporting it. The threshold that has not been crossed is a major dome failure. There is no confirmation of one. The current explosions look like the repeated venting Sheveluch has shown all year, not the sustained, collapse-driven column of April 2023. The distinction is everything. A vent puts a plume up for 10 minutes. A collapse puts a sustained column up for hours at higher altitude with vastly more material. That is the difference between an advisory and a rerouted ocean. B-roll, seismogram traces, tsunami buoy graphics, wide Kamchatka coastline. There's one more piece to put on the table, and I've deliberately saved it for the end because it is the most speculative thing in this video, and I want you to hear it framed properly. On the 29th of July 2025, a magnitude 8.8 megathrust earthquake struck off the coast of Kamchatka. It was one of the strongest earthquakes ever instrumentally recorded anywhere on Earth. It sent tsunami warnings as far as Hawaii, Chile, and French Polynesia. And in the days that followed, Kamchatka's volcanoes began to move. Klyuchevskoy, the tallest active volcano in Eurasia, erupted. And on the 3rd of August, Krasheninnikov erupted for the first time in roughly 600 years. The head of the Kamchatka Volcanic Eruption Response Team described it as the first historically confirmed eruption of that volcano in 6 centuries, and noted it may be connected to the earthquake. Now, is Sheveluch's 2026 behavior caused by that earthquake? Nobody has demonstrated that. I'm not going to tell you they have. What I can tell you is the state of the science, and it is genuinely interesting. Large earthquakes can trigger eruptions at nearby volcanoes, but, as the U.S. Geological Survey frames it, generally only where a volcano was already close to erupting, with enough stored magma at high enough pressure. The quake doesn't create the eruption. It pulls a trigger that was already cocked. The volcanologist Clive Oppenheimer, asked about the Krasheninnikov case, called the connection plausible, noting there is statistical evidence that very large earthquakes may trigger some eruptions within a few hundred kilometers, while adding that the mechanisms are not well understood. Plausible. Statistical. Not well understood. That is what honest uncertainty sounds like, and it is more interesting than a fake certainty would be. Because here is what is not in dispute. Sheveluch was already loaded. It had been rebuilding since 2023. Fresh magma was already arriving. It was, in every sense that matters, a cocked trigger, and a new dome started extruding 5 months after the largest earthquake in the region since 1952. Correlation, not proof. Hold both of those in your head at once. B-roll, pyroclastic flow footage from any dome volcano, hummocky debris terrain. So let's finish where we started. What is the actual shape of the worst case and who does it reach? Within about 20 kilometers of the mountain, this is the lethal zone. Pyroclastic density currents and debris avalanches. In 1964, the avalanche ran more than 15 kilometers and covered roughly 100 square kilometers. This is not a survivable environment, and it is not an evacuable one on the timescale involved. 75 minutes, start to finish, in 1964. Within 100 kilometers, ashfall. In April 2023, Kluchi took 8.5 centimeters. Ash, that thick, collapses roofs when it gets wet, ruins engines and water supplies, and grounds everything. Across river valleys, potentially further, lahars, volcanic mudflows. Loose ash on steep slopes plus heavy rain equals a moving river of wet concrete that follows valleys away from the mountain. Lahars are historically among the deadliest volcanic hazards on Earth. At Nevado del Ruiz in Colombia in 1985, they killed more than 20,000 people in towns that had no direct view of the volcano at all. And across the ocean, the aviation hazard. Not to people on the ground, to the corridor. In 2023, material from Sheveluch was tracked across the North Pacific. Ash from the volcano has reached Alaska before. In 2015, a plume crossed the Bering Sea and into Alaskan airspace. That is the honest hierarchy. The people at genuine physical risk live in Kamchatka. What the rest of us would experience is disruption, roots, delays, and a week of headlines. But notice how the effects scale, not with drama, with altitude. The higher the column, the further the ash goes, and the longer it stays up. Material injected into the stratosphere can circle the planet. When Pinatubo did that in 1991, it cooled global average temperatures measurably for 2 years. Sheveluch's current explosions are reaching 12 kilometers. That is the top of the troposphere, the bottom edge of the stratosphere, and exactly where the jet stream lives, the fastest conveyor belt on the planet, pointing directly at North America. That is why a mountain almost nobody can pronounce generates messages from 3 different countries' aviation authorities in a single week. B-roll. Return to the opening satellite loop, slow zoom out to the whole Pacific. So, back to that polygon over the dateline. It is still moving. As of the 22nd of July, Anchorage was issuing advisories on GOES imagery, the American weather satellite, because the cloud had drifted far enough east that the American satellite is now the one watching it. The dome is still growing. A new lava block was logged on the 3rd of this month. The magma is still arriving. 7 explosive events in 22 days say so. And the one measurement that would actually settle this, the internal state of a structure that has already outgrown its own crater, is the one measurement nobody has, because the summit spends half its life inside a cloud. That's not a cliffhanger I invented. That is the actual position tonight of the people whose job this is. If this changed how you look at a routine aviation message, subscribe and hit the bell, because this story is not finished, and when the next color code goes red, the update lands here first. And if you want to understand the mechanism that turns a pile of rock into a lateral blast, the one that killed St. Pierre in 1902 and reshaped Mount St. Helens in 1980, watch the video on screen now. Sheveluch did it first, 16 years before St. Helens made it famous. That's the story of how nobody noticed. Stay curious, stay skeptical, and check the data yourself. Every source for this video is in the description.